Hi everybody. Today we're going to talk about how to find decimal approximations for log values. Let's look at some things we already know. We already know that the log base 6 of 36 is equal to 2 because 6 to the first is 6 and 6 squared is 36, and the logarithm tells us what the exponent is. We also already know that the log of 0.001, remember that's log base 10. I know 10 to the first equals 10, 10 squared equals 100, 10 cubed equals 1,000, and 10 to the fourth equals 10,000. 0.001 is 1,000th, tenths, hundredths, thousandths. So we can talk about this as the log of 1 over 1,000. And so that would just be the reciprocal of 10 to the third. So this is going to be equal to -3. What about something like this? If we do the log base 5 of 700, we know 5 to the first equals 5. 5 squared is 25. We can use our calculators if we get stuck now. 5 cubed is 125. 5 to the fourth is going to be 625. And 5 to the fifth is 3,125. So we know that this is between 4 and 5 because 700 would go somewhere in here. But we don't know exactly what it is. We could do some guessing and checking, but I want to propose a different way of thinking about this. Let's also think about the log of 42. Again, that's base 10. Since there's no base written on there, we know 10 to the first is 10, 10 squared is 100, and already we're too big, so 42 is in between. So we know it's between 1 and 2. And that one we can actually calculate on our calculator fairly quickly. If I press in, now on this calculator I have to press the number first and then press the log key. So I'm going to press 42 and the log key is down here, enter, and I get 1.623 and so on. This is an irrational number. It goes on forever and never repeats. So log of 42 is an exact answer, and it's approximately equal to 1.623. I'm just going to do 3 decimal places. 1.623. So base 10 logarithms we can do on the calculator, but base 5s may take a little bit more work. Some fancy calculators let you change bases. But here's the idea about how to change a base. Let's talk about the change of base formula. And I encourage you to write this one down. The change of base formula says log base b of some number n. And it doesn't matter what the base is and what the number is, but you can rewrite this as log of n. Notice there's no base there, so that's a base 10. Log of 10 divided by log of b. And that we can do on the calculator. So let's go back to our log base 5 of 700 as an example. If we do log base 5 of 700, the base is 5, the number is 700. We can't do base 5 on many calculators, so I've got to use this change of base formula. So it's going to be the log of the number 700 divided by the log of the base, log 5. Now when we use our calculator on this, we have to be careful. This calculator, and if you're using your phone as a calculator, you're probably going to have to do the same kind of thing. You got to type in the number first and then the logarithm, divided by the number and then the logarithm, and then we're going to have to equals. So I'm going to clear this out, and I'm going to do 700, take the log of that, divided by, you can kind of see on my calculator, it shows us what we're doing. I got to do log of 5, so I type in 5, and I want the log of that also. So it's telling me what I'm calculating, but I still have to press the equal sign to get the final answer on that. So it's 4.07. So I'll write that down. This is approximately 4.07. And that's how you do the log of another base on the calculator. We expected it to be between 4 and 5, and it is. So make sure you know how to use this change of base formula.